Okay, here we go, question 7b. Again, we're going to solve this thing algebraically. Once again, this is two quadratics here. Now this is a little bit more complicated of a problem. You can see that just because of the little fractions there. But we approach it the exact same way. I mean, I've got quadratic equal to, quadratic and quadratic both equal to y. So I'm just going to set them equal to each other. This is going to equal 20 plus 7x minus 1/2 x squared. Okay, well, I don't like using the fractions here, so I could multiply through by a common denominator of 2 to get rid of those. But I notice here that when I bring this term over at negative 1/2, when I bring that over to this side and add it to this one, the 2 halves are going to become a whole. So this is actually going to become x squared when I bring that over. And so now I'll bring the 7 over, so it'll become minus 27x. And then I'm going to bring that 20 over, and it'll become plus 180 is equal to 0. Okay? And so now what I've got here is a quadratic that I'm going to solve here by factoring. I'm pretty sure this can be factored. Okay? I can always check my discriminant to see if in fact it can be factored here, but I'm pretty sure that it can. 180, what have I got here? Factors of 180 that differ by 27. I want to say, let's just check a look here. 180. You know what? I'm lazy. Normally I would go through and kind of fight with this, but I'm lazy today. Let's just do this. Let's use the quadratic formula, and this is probably good practice for us anyway. So this will become negative 27 squared. Now notice that I've put the negative in with the 27 inside the brackets. Please remember to do that. Minus 4ac all over 2 times a, which in this case is just 1. So this will become 27 plus or minus. Now I'm going to evaluate what's inside there, and I will do it like this. I'll show you what I'm doing. Okay, negative 27 close brackets squared, so I want to make sure that the negative is separate. Minus 4 times a is 1 times c is 180, and I get 9. Okay, and I figured that it felt like it should be factorable. So this will be the square root of 9 all over 2. And so, well, this is quite easy because the square root of 9 is 3, so it'll be 27 plus 3 over 2. So 27 plus 3 is 30, divided by 2 is 15. 27 minus 3, okay, is going to be 24, divided by 2 is 12. So my two values of x are going to be 15 and 12. Now, I'm going to go back up, I'm going to go back up into my original equations here. I'm just going to pick one. Okay, let's say, I don't know, let's say the first one. And I'm going to plug in my two values here. So if x is equal to 15, okay, from my first equation, that's going to be y equals 1/2 15 squared minus 20 times 15 plus 200. So I'll go to my calculator here. So 0.5 times 15, close bracket squared, whoops, sorry, you can't see that, minus 20 times 15 plus 200. And I'm getting 12.5. Now, I might want to convert that to a fraction, or not, but 25 over 2. So y is going to equal 25 over 2, and this gives me the point, therefore, 15 comma 25 over 2. If x is equal to 12, I will redo this as 1/2 12 squared minus 20 times 12 plus 200. So again, we'll go into this and make this 0.5 times 12 squared. What is this? Minus 20 times 12 plus 200, and we get 32. So the point that I'm getting out of this one is the point 12 comma 32. So those are my two solutions. Whoops, drawing it too low. 15 comma 25 over 2 and 12 comma 32.